Prior to the 20th century, the most widely accepted view of the atom was based upon John Dalton's model proposed in 1803, which stated that all atoms are fundamental, indivisible particles that make up all matter in the universe. As simplistic and as rational of an idea as this seemed, there were some concerns arising that caused some questioning of this idea by the late 19th century, and by 1897, a key discovery made by one experimental physicist led to the ultimate collapse of this early model of the atom and ushered in a new era dominated by subatomic particles. J.J. Thomson first developed his passion for physics when he enrolled in Owens College in Manchester when he was only 14 years old. His mathematics professor recognized his brilliance during his time there and encouraged him to apply for scholarship at Trinity College, which he ended up getting. Once at Trinity, he stayed there for the rest of his life. In 1895, he turned his attention towards a hot topic at the time: cathode rays. To conduct experiments for these rays, Thomson set up a Crookes tube with the following components. A cathode and anode were placed at the starting end of the tube. Close to the other end of the tube were two oppositely charged electric plates at opposite ends of each other. A phosphor coating covered the far end of the tube so that it would light up upon the ray's contact with the glass. After testing different orientations with the electric plates, Thomson discovered that when the rays were fired, they would always bend towards the positively charged plate when it passed by it. Thomson repeated this test multiple times, using different metals for the cathodes and anodes, as well as using different gases inside the tube to rule out those variables as contributing factors to the ray's behavior. They did show no effect on the ray's tendency to bend towards the positively charged plate, so Thomson concluded that the rays must have consisted of negatively charged particles that he called corpuscles. While this was a significant discovery, Thomson didn't stop there, for his work was not complete. He continued to repeat his experiments, but replaced the electric plates with a large electromagnet in such a way that the rays would pass between the two magnetic poles on their way through the tube. The rays bent with this setup as well, and after measuring the angles at which they bent from both electric plates and magnetic poles, Thomson was able to calculate the mass-to-charge ratio of these negatively charged particles. This ratio turned out to be extremely small, and through the math, he found that the size of these corpuscles were 1/2000th the size of a hydrogen atom. Thomson then shared his findings with the world, proposing corpuscles as incredibly small negatively charged subatomic particles that were found in all atoms.